Hello and welcome to Redneck Academy, the academy for normal Americans that don't really like supporting them commies over there in Khan or Khan Academy or wherever the hell that country is or those people go. Today, we're going to learn about PNP transistors, and we got a nice problem here, good and picked out for you right. So, the first most important thing to understand when doing a PNP transistor problem is you must first understand the PNP convention. So right here, I've got two nice diagrams for you. We've got the PNP convention diagram where you can see your IE and your IB and your base, your emitter and your collector, all nice and labeled out for you right quick. The next thing to know is that the PNP transistor can work or not work in a couple different states. We have the forward active, we have the cutoff region, we have the saturated, and we have the reverse active. So we got a nice problem here, nice picked out for you right quick, and that problem is wondering what state is this transistor functioning in with the following conditions: a VS at 5 volts, a VA at 5 volts, RM at 500 ohms, and an RM at 1 ohm. So with a beta of 150. So the first thing that we're going to do is we're going to solve this in a couple steps. First off, we're going to pick one of the regions, and we're going to test to see if it's in that region by looking at a couple conditions. So the first condition that we'll look at is the active region. So when this is functioning in the active region, you can replace the transistor with a current-dependent current source. So we'll do that right quick here. So now we've got a current-dependent current source. So going back to the knowns for this setup, we know that both the voltage sources are 5 volts. So we'll write that in here, 5 volts. We know 500 ohms, and we know 1 ohm. So, excuse me, ladies and gentlemen, sorry about that. I darn near pissed myself. I had to run news to John before carrying on. So anyway, back to this problem. Going back to how I knew that this is a current-dependent current source, the way that I knew that is I went on that there Worldy Pipe internet webs thing, and I looked up what a PNP transistor does when it's in the forward active region. So going off of that, what you're going to do is anytime you're checking any of these regions for a transistor, what you're going to do is you're going to look up on the internet webs or textbook or something what the transistor does in any of these regions and what conditions must be met for it to be in one of these regions. So continuing on with the forward active, testing this to see if it's in the forward active region, what we're going to do is we're going to check to see that is IB greater than 0 volts and is VCE greater than negative 0.02 volts. And so if both these conditions are met, then we know that the transistor is in the forward active region. So the way that we're going to do this is we're going to check first to see what IB, if we remember from our convention, we know that IB is right here. And we're going to do a KVL around this loop to check and see what to solve for IB. So let's do a KVL. So we know it's 5 volts minus 0.07 volts minus IB times 500 ohms minus 5 volts. This is all equal to 0. So what we do now is we got IB is equal to 0.7. Oh, my bad right here. I didn't mean this to be 0.07. I meant 0.7 volts. 0.7 volts over 500 ohms. Plug that there into your calculator, and you get that IB equals negative 0.0014 amps. And we know that this is not greater than 0. Therefore, this cannot be in the forward active region. So moving on, next thing we'll try the cutoff region. So in the cutoff region, the transistor gets replaced with just an open circuit. So also, we know that in the active region, or in the cutoff region, my bad, in the cutoff region, we know that VBE, for it to be in the cutoff region, VBE must be greater than 0.5 volts, negative 0.5 volts, and VBC must be greater than negative 0.5 volts. So we're just going to do the exact same thing to solve for VBE and VBC and check these conditions. So we'll do a KVL to solve for VBE. And so to do that, we got to first go and put in which is where. And so we know that VBE is right here. Minus, of course, this is all based off of our PNP convention. We know VBC is right here. And so, oh, and those sign conventions are plus, minus. And so since this is an open circuit, when we're doing our KVL, we know that the current here is 0. So when we do our KVL, we can get that VBC minus 5 volts plus 5 volts equals 0. And so going off that, we get that VBE equals 0. So now when we check this condition, yes, 0 is greater than negative 5 volts, so we good. Next, going on to VBC, doing a KVL again, we get VBC minus 5 volts equals 0. So we get VBC equals, we get that VBC equals 5 volts, which 5 volts is greater than 0. So we found that this PNP is in the cutoff region. So now if we had found that this transistor is not in the cutoff region, then we would have just gone back and looked up the conditions for saturated, put it in, and just solve for it there and check that. And if it wasn't that, then we would know it had to be the reverse active. So basically, this is your foolproof method even a redneck can do to solve for any PNP transistor. Just check to see what condition it's in. Thank you, and see you next time on Rednecks Do Academy and stuff.